Welcome everyone to the project course. We are going to create the project for facial image prediction using ResNet. We are going to discuss about the concepts like how to import the dataset for our project and how to pre-process the data, and then how to build the ResNet 50 model and how to compile the model, and then we are going to discuss about how to train the dataset using ResNet, and then we are going to use the trained model to predict the facial image. So this project course is very useful for the students who are trying to create ResNet project for the first time. So let's get started. Welcome everyone. In today's class we are going to create our project facial image prediction using ResNet. For our project we are going to use Google Colab. So you have to create new notebook. So after creating the new notebook, you have to type your project name. So I am going to type face prediction using ResNet. So you can type your own project name. So after typing the project name, we are going to change our runtime. So I am going to select T4 GPU. For training our ResNet model, we are going to select GPU. So now we are going to discuss about what are all the packages we need to import for our project. So first we need to import CV2 package. So I have to type import CV2. For reading the image, we need to import CV2. So after that, you need to import OS. And then we have to import NumPy. For numerical calculations or creating array, you have to use NumPy. So after that, we need to import ResNet 50. We are going to use ResNet 50 for our project. So before that, we need to import the TensorFlow Keras package. You have to type from TensorFlow.keras applications import ResNet. So ResNet 50 is the subpackage of TensorFlow Keras. So after that we are going to import TensorFlow dot Keras dot models import model comma load model. We are going to load the models from the TensorFlow and then Keras. After that we need to import TensorFlow dot Keras dot layers. We need to add layers for the training purpose. You have to import dense and then global average pooling 2D. We are going to use 2D layer for the ResNet, and then we are going to import TensorFlow dot Keras dot preprocessing dot image import image data generator. So for optimizing our model, so after that you have to import from TensorFlow dot Keras optimizers. So for optimizing our training, we need to import the package Adam. It will optimize our training dataset. So after that we need to import TensorFlow dot Keras dot utils import to categorial. And then we are going to import sklearn package for splitting our data set. You have to type model selection, import, train test split. We need to import the packages for training the dataset and splitting the dataset. So these are all the packages we need to import for our project. You have to run the code. So you can see all the packages are successfully imported. In the next class, we need to load our dataset. Welcome everyone. In today's class, we are going to discuss about how to load and pre-process our dataset. So I'm going to use my Google Drive. So because the Google Drive contains my dataset. So I have to mount the Google Drive. So in the Google Drive, you can see my dataset, face recognition. So that's my dataset. So inside that you can see 3 folders. So each folder contains the facial images. So the first one is the Bill Gates. You can see all the images for the Bill Gates facial image. Also you can see other dataset. So you have to download the dataset from the description, or you can also download the dataset from the Google website. So after that we have to load our dataset. To create a function def load dataset of, and then you have to type the dataset path. So inside that we need to create array for the images, labels. You have to create array for gathering the images and then storing the labels. We need to create array, and label map for mapping the labels with the images. You have to create, and then you have to type the count of the label. Create a for loop for creating the labels. You have to create a for loop for label name in OS dot list directory. We are going to list all the directories in our dataset. So the data path contains our dataset. So inside the for loop, we have to create labels for our dataset. So you have to type label directory will be the OS path dot join of dataset comma label name. So the label directory will be the dataset path and then label name. So every folder will be the label. Bill Gates will be the label. Dwayne Johnson will be the label. Will Smith will be the label. After that, we are going to use the if condition if os.path is directory of label directory. So if the path of the label directory is same as the OS path directory, then we are going to create labels. You have to type label map of label count. There will be 3 labels, there will be 3 count. Label name. We are going to map the labels in the folders. For image name in OS list directory of label directory. So the folders will be the label directory. Bill Gates will be the label directory. So inside the Bill Gates directory, we can find the images. So we have to extract the images from the Bill Gates. So you have to type image path equal to os dot path dot join label directory comma image name. How to extract the images. Now we are going to use CV2 package for reading the images in the folder. For that only you have to type cv2 dot im read image read of image path. So we are going to read all the images from the directory. Resize the images. You have to type image equal to cv2 dot resize image comma 224 comma 224. You have to resize the images for the training, and then you have to append the images to the array. So we created array for the images. After reading all the images, we are going to create array, and then you have to create labels, append label count, and then you have to increment the count one by one. Based on your folders, the count will be increased. So after that, we need to convert the images to array. You have to type np dot array of images. We have to convert the images to array using the numpy. You have to type the data type will be float 32 divided by 255.0. So after that, we need to convert the labels to category. So category can be Bill Gates, Dwayne Johnson or Will Smith. For that, you have to type to categorial of labels. It will be converted to category. So based on the category, we can predict the image. So we have successfully loaded and pre-processed our data. So you have to run the code. So in the next class, we are going to build our ResNet model. Welcome everyone. In today's class, we are going to build our ResNet 50 model for training our dataset. So we have to create a function for building the model. So you have to type def build ResNet of input shape, comma number of classes. So after that, we have to use the base model for the ResNet 50. You have to type base model equal to ResNet 50 of, you have to type the weight equal to ImageNet. So ResNet 50 will use the base model ImageNet, comma include top equal to false. It will start the ResNet 50 architecture. And then you have to type comma input shape equal to input shape. So we are going to use the base model ImageNet for the ResNet 50. So after that, you have to type the output base model dot trainable equal to false, and then you have to type x equal to base model dot output. So we are not going to train our base model. For that only you have to type false. ImageNet will not be trained, only ResNet 50. So after that, you have to add the layers for the ResNet 50 model 2D of X. So we need to add layers for more accuracy and training for our dataset. And then you have to use the dense activation. You have to activate your dense layers of X. We have to type prediction equal to dense of number of classes. So based on the class, it will predict the output. And then activation equal to softmax. softmax of x. So x will be our base model output. And then you have to type model equal to model. You have to type capital M model of input. Input will be our base model dot input comma model equal to predict comma output will be prediction. So you have to run the code for building our ResNet 50 model. So you can see our model is successfully built. So in the next class we are going to train our dataset using ResNet 50. Welcome everyone. In today's class we are going to train our dataset using ResNet 50. So for that you have to type the values. First we need to type the dataset. You have to copy the path of your dataset and then paste. So that's our dataset, face recognition. And then you have to type xy comma label map. We need to load our dataset. Load dataset. You have to type the variable data path. It contains our dataset. So now we have successfully loaded our dataset. So after that we need to split the dataset. For that you have to type the variable xtrain, xtest, ytrain and ytest. And then you have to type the package train test split. So inside that you have to type the values x, y, test size equal to 0.2, 20% for the testing, 80% for the training. And then you have to type the random state equal to 42. So after splitting the dataset, we have to create image data generator. So you have to type the variable data gen equal to image data generator of. So inside that you have to type the values like rotation range, width shift, height shift and horizontal flip. So you have to type the value rotation range equal to 20. And then you have to type the width shift range equal to 0.2 and then height shift range you have to type range equal to 0.2 and then you have to type the last value horizontal flip equal to true. So these are all the values we need to create for the data generator. So after that you have to type data gen validate equal to, we need to validate our image data generator datagen dot datagen validate dot fit of X test. So it will optimize the data set. So after that, we need to compile the model. So before compile the model, we need to build the model. So you have to type build ResNet. We are going to call the previous model function build ResNet. And then you have to type the input shape. So input shape will be 224, 224, 3. So you have to type number of classes and then any. And then you have to type classes will be the len of label map. So there are 3 folders and then there are 3 classes. So number of classes will be 3. Now we need to compile the model. So you have to type model.compile of. First you need to type the optimizer. For optimizing our model, you have to use the Adam. It will optimize our model. So you have to type the landing rate equal to 0.001. And then you have to type the loss. The loss will be categorical cross entropy, comma, and then metrics will be accuracy. We are going to find the accuracy for our model. So we have successfully built and compiled the model. So now we can train the model. For that you have to type history equal to model.fit of. So inside that we need to type the epoch and then batch size. DATASET dot flow of X train, comma, Y train, comma, batch size equal to 8. So I'm going to choose 8. So after that, we are going to type the epoch. I'm going to type 30. So 30 epoch for the training. And then validation data equal to DATASET validate dot flow of X test, Y test and batch size equal to 8. So we need to train and then validate. For both we need to type batch size. For validation we are going to use testing dataset. For training we are going to use training dataset, X train and Y train. So you have to run the code for training our dataset. So you can see our training process is started. So you have to wait for 30 epoch. Also you can see the accuracy score for every epochs. So based on your data set, the process will be longer or shorter. So you can see all the accuracy score for every epochs. So I'm going to complete the training. So you can see our training process is completed. And also you can see the accuracy score 81%. So 81% our model is trained. So in the next class we are going to complete our project. Welcome everyone. In today's class we are going to complete our project. So in the previous class we have trained our model. Now we are going to use the trained model to predict the output. So you have to type model.save of. Inside that you have to type the model name face.h5. we are going to save the model in keras format. So you can see the model. You have to reload and then you can see the model face.h file. So that's the keras format. So after that we are going to use our trained model to predict the data. So for that we are going to create a function predict of model, our trained model comma image. We are going to use image for the prediction. And then label map. We are going to use image model label. Now we are going to use the cv2 package to read the image. cv2 dot image read of image path. It contains our image. So after that we are going to resize the image. Image comma 224. So after that you have to type image equal to np dot expandings of image comma axis equal to 0. Divided by 255.0. Now we are going to predict the output. You have to type prediction equal to model dot predict of the image. And then we are going to print the prediction. You have to type print of label map labels before that you need to type label equal to np dot argument max of prediction. So after that we are going to predict the output. You have to type predicts equal to load model of face.h file. So that's our trained model. Comma, you have to type the path of the image. So I'm going to copy the Bill Gates and then paste the image path. Comma label map. So after that you have to run the code. So hope you learned something from this project. If you want to download my code, it will be present in the description. So let's see on the next course taught by me.